You just watched me flip a switch. All of your life experience prior to this moment has led you to believe that something interesting will probably happen next. Only, bad news for you, bucko. You're at the bottom of the YouTube rabbit hole. Nothing interesting is going to happen, except you're still going to sit there like a good boy watching a static screen for the next 10 seconds, questioning your life decisions, and somehow still be disappointed when you discover that the only thing this box does is this. And now you're going to keep watching to find out how I built it. I started this project by launching Tinkercad's free circuit design software to prototype an Arduino-based circuit that could fit inside of a handheld box. I then wrote a program for the Arduino to control the servo and cycle the finger through a series of preset motions to give the box a bit more personality. I then used Fusion 360 to design the 3D printable parts. There's 4 in total: the case, 2 lids, and a finger that flicks the toggle switch. The finger is actuated by a 17-gram servo, which is controlled by an Arduino Uno, all of which is powered by a 9-volt battery. When the battery is connected, the Arduino constantly monitors the status of the switch. So when you flip the switch, the Arduino instructs the servo to rotate to a preset position that's written into the Arduino code, which incidentally causes the finger to flip the toggle switch back to its original position. And because that weak animal brain of yours can't stand the idea of losing this now incredibly existential competition between man and machine to a robot that lives inside of a plastic box, you decide to flip the switch one more time, unknowingly having restarted the whole thing without any chance of ever winning. The next step was to 3D print all the parts. I printed the case and both lids in black PLA using my desktop FDM 3D printer with minimal support material, and I printed the finger in white PLA to provide extra visible contrast. It took 12 hours to print all the parts with a 0.2mm layer height following the quality settings in Prusa Slicer. It was then time to wire up the electronics. The first step was to solder leads onto the toggle switch, which would be connected to one of the Arduino's digital input pins. I then soldered an additional lead to the toggle switch to split the power supplied by the 5-volt pin on the Arduino between the switch and the servo. I also soldered a 220 ohm resistor to the negative lead on the toggle switch and then connected it to ground. This resistor then acts as a pull-down resistor to ensure that the digital input pin on the Arduino consistently reads a low signal whenever the toggle switch remains unflipped. I decided to power the system with a 9-volt battery that's housed in a case with its own on-off switch. I wanted this switch to be conveniently located, so I made sure to include a viewport at the bottom of the case so you could easily toggle it on and off. Unfortunately, the connector for the 9-volt battery case was too large and would interfere with the walls of the box when plugged in, so I decided to cut off the connector and instead supply power to the system via the Arduino's voltage input pin. And because the battery's leads were too flimsy to insert directly into the Arduino's pins, I ended up having to solder on some extensions made from 22-gauge solid core wire. I made sure to slip heat shrink tubing over all the soldered connections and then was ready to install the electronics into the box. To assemble the box, you need 3 types of screws, 4 6x3mm magnets, and a hot glue gun. The first step is to lower the Arduino and the battery into the case. The Arduino then gets fastened to the bottom of the case using 3 4 by 3/8 inch pan head tapping screws, which pass through holes in the Arduino into corresponding mounting posts. The battery then gets hot glued into place with its on-off switch centered over the viewport in the bottom of the case. The 17-gram servo is then placed into position and then fastened to the wall of the case using the 2 screws that were included with it. Just be careful not to strip the screw heads here because you have to hold the screwdriver at an angle to clear the wall of the case. The finger is installed next. I designed the finger to have an interference fit with the servo's metal gear such that the gear teeth cut grooves into the plastic finger to create a solid mechanical connection and help prevent torque out. Next, the toggle switch gets installed into the fixed lid, making sure to get the orientation correct such that the finger can push the switch away from it to turn it off. The lid then gets fastened to the case using 4 4 by 1/2 inch flathead wood screws. The 4 permanent magnets are installed next. The purpose of these magnets is to hold the hinging lid down with enough force such that it won't fling open when the case is held upside down. However, the magnets don't apply too much force, so the finger can still open the lid. It's important to get the polarity of the magnet pairs correct before inserting them into the pockets, because otherwise the repulsive magnetic force would prevent the lid from closing. Once the magnets are inserted into the pockets with the correct polarity, it's a good idea to apply a small dab of hot glue just to hold them in place. The hinging lid can then be installed by screwing in 2 4 by 1 inch pan head self-tapping screws into the corresponding holes in the case such that the screws then act as hinge pins. I recommend that you tighten these screws with a shim inserted in between the lid and the top of the case to ensure that the lid will sit flush with the case when closed. Oh yeah, don't torque the hinge screws all the way down because that will restrict the motion of the lid. This is a great time to power up the system and upload the Arduino code using the USB port accessible from the side of the box. Uploading the code will cause the servo to return to its neutral position. You then need to remove the finger from the servo and then reclock it to an upright position so that it's touching the toggle switch. This becomes the servo's new 0 position, so any positive number entered into the Arduino code will cause the finger to rotate backwards away from the switch. You've done it. You've built an over-engineered, useless box and are ready to test it out. Aren't you proud of yourself for spending all this time and effort to build something that literally has no purpose? Feels good, doesn't it? And now the moment you've been waiting for. Prepare to be disappointed.